From a distance, it glows like a sapphire suspended in the dark, a dazzling blue world that whispers promises of oceans and life. But the closer we look, the truth unfolds, like a horror story. This is no paradise. On HD1 89733b, storms scream faster than sound, and shards of glass rain sideways through the air. At Dual Suns, we uncover the cruel beauty of a planet that looks like heaven but lives like hell.
One Earth, two suns, infinite questions. This is Dual Suns.
When we speak of distant worlds, it is easy to imagine them as tiny dots scattered across a star map. Numbers like 64 light years away sound almost abstract, as if they belong to a realm beyond human comprehension. But let us bring this down to scale. 1 light year is about 6 trillion miles. Multiply that by 64, and you get a distance so immense that even the fastest spacecraft humanity has ever built would take millions of years to arrive. And yet, in cosmic terms, HD 189,733b is practically a neighbor, close enough for our telescopes to peel back its secrets. This strange planet orbits a star located in the small constellation known as Vulpecula, or the Little Fox. It is not a bright constellation you can easily point out in the night sky, but within that faint pattern lies one of the most bizarre exoplanets ever discovered. For astronomers at NASA and the European Southern Observatory, HD 189,733b became a favorite target because of its proximity and its dramatic personality. Now, let us talk about size. If you picture Jupiter, the king of our solar system, you will have a solid reference point. Jupiter is enormous, so big that more than 1,000 Earths could fit inside it. HD 189,733b is what scientists call a hot Jupiter. It is roughly the same mass and size as Jupiter, slightly larger in radius, but unlike our distant gas giant that lingers far from the sun, this alien world hugs its parent star so tightly that it completes an orbit in just 2.2 Earth days. That is shorter than a long weekend. Imagine if your entire year lasted only 2 days, birthdays, seasons, anniversaries, all compressed into a cycle shorter than binge watching your favorite series. To put this into perspective, Earth takes 365 days to complete its orbit around the sun. Even Mercury, the speed demon of our solar system, needs 88 days. But HD 189,733b, it races around its star with a kind of reckless urgency, like a sprinter who never slows down. This close orbit means the planet is locked in a constant tug of war with its star's gravity and radiation. It lives in a cosmic pressure cooker, and the consequences are nothing short of catastrophic. Now, here's where the comparison becomes fascinating. Jupiter, despite its size, is far from the sun and remains a cold giant bathed in soft sunlight that barely warms its cloud tops. HD 189,733b, on the other hand, is like Jupiter shoved dangerously close to a blazing furnace. It is a gas giant caught in an endless broil, a celestial marshmallow held too close to the fire. While Jupiter floats serenely in the outer solar system, this hot Jupiter is constantly scorched, its atmosphere whipped into chaos. Think about this. The distance between Earth and the Sun is about 93 million miles. Astronomers call this one astronomical unit. HD 189,733b orbits its star at a fraction of that, less than 3 million miles away. That is 30 times closer than Mercury is to our sun. If Earth were moved that close, our oceans would boil away in an instant, our atmosphere would ignite, and our planet would become an uninhabitable husk. HD 189,733b survives there, but survival comes at a cost. Unimaginable winds, blistering heat, and violent weather that make our fiercest hurricanes look like gentle breezes. When scientists discovered how quickly this planet whipped around its star, they immediately suspected it would be a hostile environment. A gas giant that close could never resemble Earth in any meaningful way. And yet, What captured the imagination of astronomers was not just its orbital speed or its inflated size, it was its color. Through telescopes, HD 189,733b gleamed with a rich blue hue, so striking it looked almost like our own planet from space. At first glance, it seemed like a mirror image of Earth, as if nature had painted another sapphire world among the stars. But as we will soon uncover, that familiar blue is nothing like our oceans. It is not a reflection of calm seas or gentle skies. It is a trick of chemistry and light, a mask hiding the violence underneath. And to understand why, we must first grasp just how extreme this planet's orbit makes it. The very position of HD 189,733b dictates everything. Its unbearable heat, its screaming winds, its glassy rain. At dual suns, we often remind ourselves that context is everything in astronomy. Place a planet at the right distance, and you may find life. Place it too close, and you find hell. HD 189,733b is the perfect demonstration of this cosmic rule. A giant nearly identical to Jupiter, but with its orbit compressed into a frantic 2-day sprint, forever chained to a star's fiery embrace. And so the stage is set. We have a planet roughly the size of Jupiter, orbiting impossibly close to its star, glowing like a jewel against the black of space. But do not be fooled by appearances. And so, the stage is set. We have a planet roughly the size of Jupiter, orbiting impossibly close to its star, glowing like a jewel against the black of space. But that dazzling blue light is not the promise of oceans or calm skies. It is the reflection of something far more violent, a signal written in storms and shattered glass. To understand HD 189,733b, we must peel back the mask of its blue beauty and face the chaos beneath. When astronomers first captured the light of HD 189,733b, they were stunned. Against the black velvet of the universe, this planet radiated a deep cobalt blue, the kind of color that makes you stop and stare. To the human eye, it looked almost familiar. From far away, it could be mistaken for Earth itself, a twin world glittering with oceans and skies, waiting to cradle life. Imagine the iconic blue marble photograph of Earth taken by the Apollo astronauts. Our planet appears serene, wrapped in a delicate swirl of clouds, oceans gleaming with sunlight. Now place that image beside HD 189,733b. At a glance, they could be siblings. Both are glowing orbs of blue, suspended in the dark. And it is here that our imaginations leap ahead. Perhaps this alien planet hides seas as wide as the Pacific, or storm systems no different from a hurricane off the coast of Florida. But beauty, as it turns out, can be cruelly misleading. The truth of HD 189,733b's color is not a story of water, but of fire, storms, and shattered glass. The blue hue is created not by oceans reflecting sunlight, but by something far more dangerous, tiny glass-like particles suspended in its atmosphere. These silicate crystals scatter the blue wavelengths of light, just as Earth's sky scatters sunlight and paints our world blue. The difference, however, is terrifying. On Earth, scattering gives us clear skies and gentle sunsets. On HD 189,733b, scattering is a warning, a signal of violent storms where those glass particles are whipped sideways by winds faster than any hurricane we have ever known. Think about it this way. Picture standing at the beach in California, watching sunlight dance off the surface of the water. That is how our minds want to explain. HD 189,733b's glow comforting, peaceful, recognizable. But the reality is, closer to standing in front of a tornado that is shredding buildings into fragments of glass, then flinging those shards across the sky at thousands of miles per hour. The planet's color is not an invitation. It is a hazard sign written across the cosmos. This is one of the cruel tricks of exoplanets. We search the skies for worlds that remind us of home, and sometimes the universe seems to oblige, dangling a lookalike just out of reach. But the lesson of HD 189,733b is that appearances are deceiving. The familiar blue of Earth means safety, water, and life. The blue of HD 189733b means danger, heat, and storms unlike anything we have experienced. And yet, that is exactly what makes it so fascinating. A world that looks like paradise, but is in fact hostile to life as we know it, challenges our instincts. It forces us to ask how many other planets out there might look friendly from afar but hide deadly truths. What if the color of life on one world is the color of chaos on another? HD 189733b's glow is not just a scientific curiosity, it is a cosmic riddle, a reminder that our senses can trick us when we gaze across the stars. At Dual Suns, we do not stop at the surface illusion. We dive deeper, peeling away layers of beauty to reveal the truth hidden beneath. And on this world, that truth is written in storms so fierce they could tear apart anything that dares to enter. So, as we continue our journey, remember the lesson of the blue. What looks like Earth from a distance is in fact a mirror of chaos. The jewel-like shine of HD 189733b is not the promise of oceans, but the signal of an atmosphere turned into a weapon by physics itself. To understand this planet, we must now step inside those raging skies, where winds scream louder than thunder and the rain cuts sharper than knives. Step closer into the skies of HD 189733b and the illusion of beauty shatters instantly. Here, weather is not a passing inconvenience. It is a weapon of nature, operating at a scale so brutal that Earth's most terrifying storms feel like gentle breezes by comparison. On Earth, hurricanes are among the fiercest displays of weather we know. Take Hurricane Katrina, one of the most destructive storms in American history, which reached wind speeds of about 175 miles per hour. That was enough to flatten entire neighborhoods, tear apart levees, and change the lives of millions. Now imagine winds not at 175 miles per hour, not even at 500, but at 5,400 miles per hour. That is the speed of the winds that scream endlessly across HD 189733b. To put that into perspective, 5,400 miles per hour is 7 times faster than the speed of sound. It is like a hurricane that has been placed on steroids by the laws of physics, ripping across the atmosphere with unstoppable force. If Katrina was a monster storm, then HD 189733b is an army of monsters circling the planet endlessly without pause. And the wind is only part of the nightmare. Imagine what those winds carry. On this world, rain does not fall as water. Instead, the atmosphere forms silicate particles, tiny shards of glass that fall as rain. Now picture those fragments being swept sideways by supersonic winds, cutting through the skies like a billion tiny blades. If you have ever seen an industrial sandblasting chamber, you know how even soft grains of sand can strip paint from steel. Now replace those grains with glass, sharpen them into microscopic knives, and blast them through the air at several times the speed of sound. That is the storm you would face here. No spacesuit, no armor, no technology we currently possess could protect a human body in such an environment. You would not survive a single second. Even the hardest spacecraft materials would be torn apart piece by piece, as though the planet itself were grinding down anything daring enough to enter. This is why HD 189733b is sometimes described as a hell world, not because it burns with fire and brimstone, but because its very air is turned into a weapon. The winds alone would destroy cities. The glass rain would slice through anything solid. Together, they create a landscape where survival is not only difficult, it is impossible. Think about how we experience weather on Earth. We complain about a heat wave in Arizona, or a snowstorm that shuts down New York. We measure our discomfort in degrees and inches, in delays at airports and closed schools. On HD 189733b, weather is not an inconvenience, it is annihilation. The storm is the surface. The storm is the climate. The storm is the planet. And yet, this very chaos is what makes HD 189733b such an extraordinary object of study. Astronomers are not just peering at a faraway gas giant. They are witnessing the extremes of atmospheric physics pushed to limits that Earth will never reach. In studying this planet, we are not only learning what makes it so hostile, we are also expanding our understanding of how atmospheres work everywhere in the galaxy. So when you look at that shimmering blue jewel and feel the instinct to see home, remember the reality. This is a place where beauty and brutality are the same thing. A place where the skies themselves would shred anything to pieces, and still there is more to discover. Because behind the storms, behind the winds and glass rain, lies a deeper question: what drives such chaos? What does a planet have to endure to become a world of eternal storms? The chaos of HD 189733b does not stop with wind and rain. To truly understand its brutality, we must step into the heat. Because here, even without the glass storms, even without the supersonic winds, the temperature alone makes this world unlivable. On the day side of HD 189733b, the thermometer climbs to about 1,200 degrees Celsius. To put that in perspective, that is more than twice the heat inside an industrial steel furnace. On Earth, such temperatures would melt metal, shatter concrete, and vaporize anything organic in an instant. Here, it is simply the baseline of daily life. You might think that relief would come with nightfall, the way it does on Earth. After all, when the sun sets in the desert, temperatures can plummet, giving at least some reprieve from the blistering heat. But on HD 189733b, night is no savior. Even in darkness, the planet remains a cauldron. Winds circulate the heat so efficiently that the night side is still burning hot, only slightly cooler than the inferno of day. Imagine walking out of a steel mill during the day, where molten metal glows in the furnace. Now imagine that when the lights go out, instead of cooling, the air still radiates that same unbearable heat, as if the entire world has become one endless oven. On Earth, nighttime is when we rest. On HD 189733b, nighttime is just a slower version of hell. This unrelenting heat is part of what drives the planet's violent weather. The atmosphere, supercharged by extreme temperatures, becomes a restless ocean of energy. Storms are not occasional interruptions, they are the default state. There are no calm skies, no gentle breezes, no seasonal changes. Only eternal turbulence, powered by a star that is simply too close, too intense to allow anything else. And yet, this environment gives scientists an invaluable laboratory. By observing HD 189733b, astronomers can test theories about how atmospheres redistribute heat, how they circulate energy, and how they sculpt the weather on worlds very different from our own. The findings do not just apply to this planet. They ripple outward, helping us predict climates on other gas giants, on exoplanets yet to be discovered, and even deepening our understanding of Earth's own fragile atmosphere. So when we imagine standing under its cobalt sky, we must remember, there is no comfort in the shade, no peace after sunset. On HD 189733b, the darkness does not cool the air. It only reminds us that this is a planet where survival is not an option, day or night. But even as we map its temperatures and catalog its storms, one mystery lingers. What kind of star creates such a world, and what does that relationship reveal about the fate of planets everywhere? We have seen the storms, we have felt the heat, but to step even closer into HD 189733b is to confront one more layer of hostility, the very air itself. Imagine, for a moment, what it would be like to breathe here if breathing were even possible. The first sensation would not be the burn of heat or the sting of glass in the wind. It would be the smell. The atmosphere of HD 189733b carries hydrogen sulfide, a gas infamous on Earth for its stench. It is the same compound released by volcanic eruptions and bubbling swamps, and it smells unmistakably like rotten eggs. On our world, you might catch a whiff of it near hot springs in Yellowstone or around a sulfur vent near a volcano. Now multiply that odor until it saturates the very air you breathe. On HD 189733b, the smell of rotten eggs would not just linger, it would define the entire planet. And hydrogen sulfide is only the beginning. Mixed into the atmosphere are traces of water vapor, carbon dioxide, and carbon monoxide. On Earth, water and carbon dioxide are essential ingredients of life. They shape our climate, feed our ecosystems, and make our planet habitable. But here, they exist in a toxic cocktail, stirred into a world where nothing resembling life as we know it could endure. The presence of water does not mean oceans. The presence of carbon dioxide does not mean forests. In this environment, they are only reminders of what could have been ingredients trapped in a recipe of destruction. Carbon monoxide, especially, is a silent killer. On Earth, it is the gas that leaks from faulty furnaces, the one that detectors in American homes are built to warn against. Invisible, odorless, and deadly, it suffocates quietly, stealing oxygen from the blood. On HD 189733b, it is simply part of the atmosphere, blending with other toxins into an unbreathable haze. If somehow you could stand on this planet, your senses would be assaulted from every direction. The heat would blister your skin, the winds would hurl shards of glass against your body. And before any of that destroyed you, your first breath would fill your lungs with poison. The rotten egg stench of hydrogen sulfide, the suffocating presence of carbon monoxide, and the choking thickness of carbon dioxide would make every moment unbearable. The air itself is not a gift here, it is a weapon. And yet, as hostile as this atmosphere is, it fascinates scientists. The mixture of gases tells a story about the planet's history, about the chemistry that unfolds under such extreme conditions. It challenges our ideas of what atmospheres can be, reminding us that air is not a universal comfort, but a fragile, variable thing. On one world, it gives life. On another, it delivers only death. Think about the comfort of breathing Earth's air right now. 78% nitrogen, 21% oxygen, the perfect balance for our survival. We do not even notice it most of the time. It is invisible, effortless, and life-sustaining. But on HD 189733b, air is no friend, it is the enemy. And still, astronomers keep studying it not because they dream of walking there, but because every atmosphere we decode gives us clues to the bigger puzzle. What other worlds might be out there waiting to be discovered? If one planet can be both beautiful and deadly, then what secrets do others hide in their skies? As we peel back the layers of HD 189733b's toxic air, another question emerges: how do we even know all of this from 64 light years away? What tools allow us to sniff the winds of a world we will never touch? From 64 light years away, HD 189733b seems unreachable, untouchable, a jewel forever locked behind the curtain of space. And yet, through the eyes of our telescopes, it has become one of the most studied exoplanets in the galaxy. What scientists have uncovered here is more than a catalog of extremes. It is a lesson about how worlds are built, how they live, and how they die. If Earth is a lush oasis in the desert of space, HD 189733b is the reminder that not every blue planet is a cradle for life. Its color deceives, its storms destroy, its air poisons. It is a warning carved into the cosmos. Appearances are not enough. A sapphire glow in the darkness does not guarantee oceans, does not promise forests, and certainly does not mean safety. In this sense, HD 189733b acts as a mirror, forcing us to reconsider what we expect when we search for another Earth. This is why NASA and international teams of astronomers have returned to this world again and again. The Hubble Space Telescope was one of the first instruments to decode its atmosphere, teasing out chemical fingerprints from the faintest glimmers of starlight. Later, the James Webb Space Telescope carried this work even further, with instruments powerful enough to detect subtle details: water vapor hiding in the toxic mix, the signature of carbon compounds swirling in the heat. Each observation was like running a lab test on a planet we cannot touch, reading the story of its air without ever leaving home. And that story matters, because by studying HD 189733b, scientists sharpen the tools that will one day identify habitable worlds. If we can measure poison here, we can measure oxygen somewhere else. If we can see glass rain at 64 light years, perhaps we can also see the fingerprints of biology on another planet. The technology we hone on these hell worlds will be the same technology that eventually reveals a true second Earth. Think of HD 189733b as the universe's training ground. It challenges us with conditions that break the limits of our imagination: 5,000 mile per hour winds, 1,000-degree heat, glass storms, and rotten egg skies. By solving the puzzle of this planet, we learn how atmospheres function under extremes, how chemistry shifts in alien conditions, and how to read the light of worlds far away. Each discovery here echoes outward, preparing us for the day when we encounter a planet that is not just beautiful, but also alive. And so, what began as a false promise, a blue twin of Earth, becomes a vital teacher. It tells us that the cosmos is more diverse, more surprising, and more brutal than we ever assumed. It reminds us that life is fragile, and that our own world, balanced so delicately between chaos and calm, is rare and precious. At Dual Suns, we see HD 189733b not as a disappointment, but as a revelation. It shows us that the universe does not always play by our expectations. And in that challenge, in that strangeness, lies the real beauty of discovery. But our story is not finished yet, because every planet is shaped not only by itself, but also by the star it orbits. And the fiery relationship between HD 189733b and its parent star may be the final clue in understanding why this world is such a violent place. HD 189733b began as a vision of beauty, a sapphire jewel glowing in the dark. But as we peeled back its layers, what we found was chaos. Winds faster than sound, rains of glass, poisonous skies, and heat that turns the whole planet into an open furnace. It is the perfect example of how the universe loves to play tricks on us. From far away, it whispers paradise. Up close, it roars nightmare. And that raises a question, one we cannot ignore. If this blue giant is a false promise, then how many other worlds out there are hiding terrible secrets behind beautiful masks? How many planets glow like Earth but live like hell? And on the other hand, how many look ordinary, even lifeless, but may secretly shelter oceans, atmospheres, or even biology itself? This is the heart of the great search. Every new exoplanet we discover expands the map of possibilities. Some worlds burn hotter than furnaces. Some are frozen in eternal night. Some orbit two suns, like something ripped straight from a science fiction film. Each one is stranger than the last, each one challenging what we think we know about planets. If Earth is an oasis in the desert of space, HD 189733b is the desert storm that reminds us how fragile our oasis really island. But that is not cause for despair, it is cause for wonder. Because the more bizarre, the more hostile, the more alien these planets appear, the more extraordinary it becomes that life found a way to thrive here on our tiny blue marble. So let us turn the question to you. If HD 189733b is a nightmare gem, what else waits beyond? How many more planets are hiding storms, poisons, and extremes we cannot yet imagine? And more importantly, somewhere out there, is there a blue world that really is a paradise, not a trick of the light? At Dual Suns, this is the journey we share with you. The joy of peeling back illusions, of seeing not just what is beautiful, but what is true. Tonight we saw one world of storms. In the next chapter of our cosmic story, we will meet others, planets so strange that even HD 189733b will seem almost familiar. If this journey fascinated you, make sure to subscribe to Dual Suns so you never miss the next step into the unknown. Together, we will keep exploring, keep asking, and keep daring to look beyond the glitter into the heart of the universe itself. Until next time, thank you for traveling with us among the stars. Stay curious and stay with Dual Suns.